Alright, so for this first demonstration of P1, we're going to look at its functionality for when it actually has absolutely no training whatsoever. So as of right now, P1 is actually fully trained. That can be seen by the text file which holds the Q table, which is right here. All of these values are trained to make the agent move optimally in the Unity environment once it is initialized. However, we don't want to see the effects of that yet. We just want to see how it moves without any sort of policy whatsoever. So what we're going to do is that we are going to essentially reset that table by running P1 only once and not letting it train at all, and then writing the table after only going through the environment once. So we're going to change these. We're going to disconnect P1 from Unity, which is what these 6 lines are. And then we are going to manually set these values. So retrieve table is going to be equal to 0 because we don't want it to have any values that are already inside the table. Training also has to equal 0 because we're not training here. One step only, we want that equal to 1 or true, because we only want the training loop to only happen once so that we don't actually return any values into the table. Write table equals 1 because we want to write the output table back into that text file. And then these two just stay as -1 because that means that the program is not connected to Unity at the moment. Okay, so if we run this program in command prompt, user sam downloads. Okay, so I'm in the right directory. So if I run qagent.py, and forgot to save. Agent.py. Qagnet. There we go. Okay, so now if we open up that same text file that we had opened before, we can see that we are returned only zeros. Now, the effects of this on the Unity side of things are made clear when we reconnect the script to Unity, and we will do that very easily simply by making the manual control lines of P1 comments and then taking away the comment identification hashes of the lines that connect P1 to Unity. So now that it is back and connected to Unity, if we go back to Unity and let's say we want a starting distance of, where is it? Okay. Let's say we want a starting distance of the dummy for 3, so I'll just put 3. I'll just put 3 for both the minimum and the maximum bound for its spawning, possible spawning places. Actually, I'll put 4 and 4 because it has to be an even number. And then for simplifier, we'll just let's just set it to -5. So if we run the script now, we see that that's really weird. But okay, so to the right here we have the dummy, and then over here we have the actual player. And if we press Q, which initializes the actual the connection with P1 to tell the player what to do, we will see that absolutely nothing happens. The player is just told to rest over and over and over again, because the since every single cell is a 0, the function which looks for the maximum value in each row that is a state is going to just return the first value, because all values are equal, and that function just is going to return the first value if all values are equal. So since all values are 0, it returns the first value, and the first value is going to be in the 0 column, and that is connected to the rest action. So when we don't have a trained model at all, the action of the player is just going to be to rest. Alright, so in the next video we're going to look at how the model actually trains, and then its effects on the performance of the player inside Unity. Oh, and I forgot to show one thing. So this is the visualization of the Q table as a color map, and with absolutely no training, if we run this visualization, we can see that all cells in this 75 by 5 table are going to be white. That's because absolutely no policy has been made. Therefore, there is going to be absolutely no difference in any of the values. Alright, so now that we have seen how the agent reacts when it has absolutely no policy and absolutely no experience training, we are going to train the Q table using the simulation within the P1 script. So the simulation is it simply is just a loop inside the inside P1 script. It's defined by this run Q function, which inside has this very large for loop that for I in range 0 to n episodes, and n episodes is just defined. Normally when I train this, I define n episodes as 10,000. So for each integer in the range of 0 to 10,000, go through one whole episode of the simulation. I won't go through this code step by step. I'll comment it and then turn it in with my product. So yeah, that's essentially how the program works, and then once the entire for loop is done, it sees if right table is equal to 1, or if right table is true, and if it is, then it takes the entire Q table variable and then puts it through this function up here, which then just writes it to the text file. Oh, I did not want to delete that. That would be bad. Okay. So if we want to train this, then we are going to have to bring back the manual controls and take out the Unity connection. So once again, we are going to get rid of these connections and then bring back these manual controls. So retrieve table, we want that equal to 1 because actually no, we don't, never mind. I mean, it doesn't matter because the table is instantiated to all zeros now, so we would actually get the same starting table if we retrieved it or not. So let's just put it to 0. Training is going to equal 1 because we are in fact training. One step only is going to equal 0 because we are running multiple steps. Right table is going to be equal to 1 because yes, we are updating that text file and putting a new table in. State input, position input equals -1 because we're not connected to Unity at the moment. And num episodes training down here is equal to 10,000, so that's exactly what I want. So if we save this and we run the script, and I actually did this entire process by mistake earlier, which is amazing when you just see how quickly 10,000 simulated rounds go, which is great. Like, that's it. That was like 3 seconds. So that just shows how important it is to have that simulation script, because if I did the training in real time, it would take, weeks of just actual episodes running inside Unity to successfully train this model. So we have updated the table, and that can be proven by opening it up again. So now we see that it is actually full of these values. Okay, so now if we go back to Unity, we can fully see the effects of these. So if we go to Q Learning Environment, and we'll keep the fighter and the dummy fighter in the same exact positions and see what the results are. So once again, over here, kind of halfway through the wall on the left side, is the dummy fighter, and then this is our player that is controlled by P1. So when we press Q, the movement and action decision making will actually start for P1. And it's not working. 1 second. Oh, yeah, that's right. We did not put the Unity controls back in once we trained P1. That would be important. So it was completely disconnected with Unity. That's why nothing was happening. Just got to do that. All right, okay. Got a little panicked there. Okay, same thing. And when we press Q, and it's still not working. That's interesting. Okay, I'll be back shortly. All right, I'm back. So I figured out the problem there. I was unintentionally putting the player out of the bounds of the program. So when it returned a state that did not exist in the, when it returned a state to P1, it was not the right state that it was returning. It was a different state. So I changed the position a bit. The simplifier is now sitting at -3, or x equals -3, and then the dummy fighter is going to be initialized still at 4,4. I move the camera of the scene a little bit to the left so we can actually fully see the dummy fighter. Okay, so when we start this, once again, player on the left is the agent controlled by P1. Player on the right is simply just a dummy player. And we press Q to begin the decision-making process. So that window popping up is simply the Python program running. I'm working on getting that not working, or getting that not happening. So it moves closer and closer to the dummy player, and then once it is within proximity of a punch, it punches. I'll show it one more time, because Q. So every single turn, it moves 1 unit closer, and it moves 1 unit closer. And then, after it comes within proximity of a punch, it punches, and the scene is over. All right, that is a... Oh, and I will show the visualization of this really quickly, because I'm running out of time. Oh, no, that's not what I wanted. Scenes. QViz. Yes, save. Alright, so if I visualize this now, you can see that the states and actions are quite concise. These green fields of actions are the ones that are going to be more likely to lead to an actual victory. So that's why they are greener than the rest of the table. There are more subtle differences in the rest of the table that I'm working on making the visualization separate more, but we'll get to that in the future. All right, thank you.